Sum, difference, and double angle identities are the ones we're looking at today, which is basically all the rest of that stuff on your formula sheet. We already looked at the reciprocal identities and the Pythagorean identities. And these are going to be the last ones. So these are the sum and difference identities, and these are listed as 4 different things on your formula sheet. There's the sine sum identity, which is sine A cos B plus cos A sine B. And then the sine difference identity, which is sine A minus B, which equals sine A cos B minus cos A sine B. And then there's a sum and a difference identity for cosine, and also one for tangent. And that's all of them right there. What you need to notice is, like in here, where it says cosine A plus or minus B, here it says minus and plus. That's because the cosine sum identity is a subtraction and the difference identity is an addition. That's why that plus minus is upside down. And for the tangent, A plus B is tan A plus tan B over 1 minus tan A tan B. But they're written out separately on your formula sheet, which makes it a little easier than this. Here's the first of the types of questions we're going to do using these identities. And this is the first one that's on the handout I just gave you. It says to evaluate sine pi over 3 plus pi over 4. And what some people want to do with that is do sine pi over 3 plus sine pi over 4 and kind of distribute that and then evaluate those two things separately, but it doesn't work that way because this is not sine multiplied by pi over 3 plus pi over 4. It's the sine function applied to pi over 3 plus pi over 4. So we can't just expand like you would if they were just algebraic terms. They're not. Sine is a specific function. And so we need to use the sine sum identity, which is here. So I'm going to rewrite this using that sine sum identity. It's going to become, basically this is sine A plus B. A is pi over 3, B is pi over 4. So when we write that out, it's going to be sine pi over 3, sine pi over 4, cos pi over 4. Plus cosine A, which is pi over 3, sine B, and B is pi over 4. So that's how that sine pi over 3 plus pi over 4 expands. It's this whole big thing. Not just the sine of pi over 3 plus the sine of pi over 4. Move that back out of the way. Then we have to start evaluating each of these things separately. And how do I evaluate sine pi over 3? Special triangles, right. So I'll just put the special triangles down here. 1, 2, root 3. Pi over 3 is down here. And then since it's pi over 4 as well, I'll need the other one, 1 root 2 with a pi over 4. So sine of pi over 3, sine is opposite over hypotenuse, so it's root 3 over 2. And it's positive because pi over 3 is in the first quadrant. Cosine of pi over 4 then is 1 over root 2 from that second special triangle. Also positive because pi over 4 is also in the first quadrant. Cosine of pi over 3 adjacent over hypotenuse, so it's 1 over 2. And the sine of pi over 4, 1 over root 2. So root 3 over 2 times 1 over root 2, which becomes root 3 over 2 root 2. And then plus 1 over 2 root 2. So just multiplying numerator by numerator, denominator by denominator. And they have the same denominator, so I should be able to add those together. This is going to be root 3 plus 1 over 2 root 2. You can leave your answer like that, even though it's not fully simplified. Do you know why it's not fully simplified? The square root on the bottom. So I'll show you how to get rid of that, but if you want to leave your answer like that, I'm okay with that. Although, in a multiple choice question, your answer probably is going to be in completely simplified form. So let's look at that as well. To rationalize that answer, root 3 plus 1 over 2 root 2, we need to multiply by root 2 over root 2. So times root 2 over root 2. And we'll end up with root 6 plus root 2 over 4. And that's actually the fully simplified form of that answer. All right, let's look at the next one. This is on the next page of your handout. Write as a single trig ratio. And it's again using these sum and difference identities. Basically, we just have to figure out which identity is this, and then we'll be able to do it. So this is sine A. We're going to call the pi over 6A. And the pi over 2b, and then that's a, b. So which identity is sine A cos b plus cos A sine b? Sine A plus b, right? So it's the sine sum identity. Sine A cos b plus cos A sine b, which means I can simplify this to sine A plus b, which is sine pi over 6 plus pi over 2. Get that out of there. So now that is a single trig ratio, but we should simplify it. Pi over 6 plus pi over 2. What's that equal to? Anybody know? Pi over 6 plus pi over 2? I'll just do it over here, if you can't do it in your head. Common denominator for 6 and 2 would be 6. So that pi stays as it is. What do I have to multiply the other one by? 3. So multiply by 3 over 3. That becomes 3 pi over 6. So that's 4 pi over 6. Or if I reduce it, 2 pi over 3. So the single trig ratio is the sine of 2 pi over 3. And that's the answer. So those ones are fairly straightforward. You just have to recognize which identity to use and then rewrite it. Here we're asked to find the exact value of each expression. And we've sort of done this before. We did finding the exact value of a trig ratio in the first trig unit. But what we did was like find the value of cosine pi over 4 or cosine 5 pi over 6 or those kind of things. Those were all special angles that we worked with before. So everything was a multiple of 30 or 45. So we did 30, 60, if we're talking in terms of degrees, which the first one is. So we did 30, 45, 60, 90, and all the multiples continuing around the circle. Or we did anything that had a pi over 3, pi over 4, pi over 6, or pi over 2, any number of those. But this is different because now we have cosine 15 degrees, which is not a multiple of one of those numbers, or cosine 5 pi over 12, and we haven't done twelfths before. Because they're not special angles, they're not in the special triangles. So what we're going to do is use the identities, the sum and difference identities, to change those into values that are special angles. So special angles, like I said, are like multiples of 30 degrees or 45 degrees, 60 degrees, and then any multiples of those. So you'd have 90 degrees, 120 degrees, and so on. We need to take 15 and make it into a sum or a difference of those angles. What would 15 be as a sum or difference of those angles? So which two of those could you add or subtract to get 15? 60 minus 45? Yes? 45 minus 30? Both of those would work, wouldn't they? There could be other ones too. Like you could do 135 minus 120 or something. It doesn't matter what you choose, but I'm going to try to choose angles that are in the first quadrant because then I just don't need to worry about the signs. But it doesn't really matter. Let's change this into cosine 45 minus 30. The reason we want 45 and 30 instead of 15 is that those are angles in the special triangles. So we can find the exact value for those ratios. But once we do that, then we need to look at the sum and difference identities again. And this is now a cosine difference because subtracting means, difference means subtracting, right? So we need to look down here, cos A minus B is equal to cos A, cos B, plus sine A, sine B. So this is equal to cos 45, cos 30, plus sine 35, sine 45, sine 30. Sorry, what did you say? Thought it was minus. It's a difference here, so we're using this subtraction, we're using the bottom one. So here we're using the bottom one. But if you look on your formula sheet, they're actually listed separately, so it's easier to look on your formula sheet than to look at this. So the cosine sum identity is actually an addition. And then we can start calculating those. So the cosine of 45 degrees, we're looking at that 1 root 2 special triangle. 45 degrees is here, so the cosine is 1 over root 2. And 30 degrees, that's pi over 6. So the cosine of 30 degrees is, adjacent, root 3 over 2. I'm not worrying about signs because I have angles in the first quadrant and everything's positive in the first quadrant. And then plus the sine of 45, which is 1 over root 2, and the sine of 30, which is 1 over 2. And this looks a lot like the first one we did. In fact, I think it's exactly like the first one we did, isn't it? This comes out to root 3 over 2 root 2 plus 1 over 2 root 2. Root 3 plus 1 over 2 root 2, or root 6 plus root 2 over 4. So it's actually exactly the same as the first one we did, which was the sine of pi over 3 plus pi over 4. The second one that we have is a little bit trickier. Sine 5 pi over 12. And you know, I always tell you not to switch to degrees from radians. I think for this one, maybe we should switch to degrees. It's easier. You could take 5 pi over 12 and figure out what two special angles add to 5 pi over 12. And I don't think it would be that hard to do, but I think it would be easier if we change it into degrees. So what's 5 pi over 12 in degrees? What is it? 75? So I could change this to sine 75 degrees. And then I need to look for which two angles will add up to 75 degrees. Or subtract to 75 degrees. Add or subtract.
35, 45, 30, 45.
30 and 45 will work. Sine 30 plus 45. Which, if we were in radians, we'd be saying pi over 6 plus pi over 4. It's just a little trickier in radians to figure out what the two angles are. In degrees, just because they're whole numbers, it's probably easier for you. So that's what I would suggest you do. And then that's the sine sum identity. So I need this again, right? Sine A plus B. So that's going to be equal to sine 30 cos 45 plus cos 30 sine 45. Sorry, that didn't quite fit in there. So all three that we did have the same answer. They're not all going to have the same answer, so you can't just memorize that one answer, unfortunately. But they'll all be very similar. So that's the sum and difference identities. I also want to look quickly at the double angle identities, which are the last ones on your formula sheet. The double angle identities come from the sum identities. Sine of 2x is the same as sine A plus B, where A and B are both replaced with the same angle, x, and you can see here on the right how that works out. The cosine double angle identities, the first one here comes from the cosine sum identity, and then the other two come from replacing either cosine squared or sine squared with the Pythagorean identity. So 1 minus cosine squared or 1 minus sine squared. And then tan 2x is equal to 2 tan x over 1 minus tan squared x. We can use them in the same way as we're using the sum and difference identities, or there are a few other things that we can do with them. But this one says evaluate using a double angle identity. We could easily evaluate this one using the cosine sum identity or difference identity. It happens to ask us to use the double angle identity here. What is pi over 2 if you split it into two equal angles? Pi over 2 is 2 times what? Pi over 4, yeah. So we can change this to cosine 2 pi over 4. And then use the cosine double angle identity. And it doesn't matter which one you choose. I'll just choose the first one. So, which means this is going to be equal to cosine squared of pi over 4 minus sine squared of pi over 4. Cosine of pi over 4 is 1 over root 2. So this is just 1 over root 2 squared minus sine of pi over 4, which is also 1 over root 2, which is equal to, what's 1 over root 2 squared minus 1 over root 2 squared? 0. And we already knew that the cosine of pi over 2 is 0 because we evaluated that type before.
So the double angle only works if the half of it is in the special triangle, right?
Yeah. The double angle identities work if your two angles are the same, or if you're given something like this, if you can divide that angle by 2 and you get a special angle. So say if we had, I don't know, really this question is there. You wouldn't use the double angle identities for this. Usually they're used more for simplifying expressions, because really anything that you can take half of and make a special angle is already a special angle. So you may be asked to use it this way, but really, if you were just asked to evaluate, you wouldn't do it this way. Here's one more thing. Red is a single trig identity. So you just have to identify which one it is. Which one is cosine squared minus sine squared, which is cosine 2x, where what is x? X is 30, right? So this is equal to cosine of 2 times 30, or cosine 60 degrees.